this is Madhuri at Science Idea Tips. Welcome back to another session. Today we have the lesson Motion and Time, which is there in our 7th class text. Right. So here in this, many different topics are covered. So today in this session we are going to cover these all topics. What is motion? What is rest? How can you say that motion is relative? And what are the different kinds of motion? What is called a straight line motion? And how to calculate speed? And what is uniform and non-uniform motion. So these are the topics we are going to cover in this session. So first of all, going to motion. When can you say that a particular object is in motion? When can you say? Here, if you are having some object here, okay, now you are standing here. According to you, the object is at rest. If you see that object after 5 minutes also there itself, you say that it is at rest. Both the definition we can say at a time. According to you, if the object is not moving, you say that it is rest. Okay, means the object position is not changed. If the object position is not changed according to the time or along with the time, we say that the particular object is in motion. It may be a vehicle, it may be a person or anything. And whenever the object position is changing along with the time, we say that the particular object is in motion. Okay? If the position of the object is changing, we say that as motion. If the position of object is not changing, we say that as it is at rest. Okay? Now, here we are saying one more thing also. What is this? Motion is relative. So as I said now, according to you means, now here two persons are traveling in one car. Both are sitting together. Okay? Both are sitting on one seat and both are traveling in one car. Now whenever they are traveling, according to this first person, I will say this person's name, here A and here B. According to B, A is in motion. A is at rest. According to A, B also is at rest. Now another person is there, C. He will ask B, whenever he observes that both of them are going in car, he will ask the next day, he will ask that, yesterday I have seen both of you are traveling in car, where you are going? Means they are in motion according to C. According to A, B is at rest. According to B, A is at rest. But according to C, what happened here? Both of them are in motion because along with the car they are moving. So whenever you compare with something else, if that is moving, then you say that something is moving there. Now I am standing here. If somebody is moving before me, I will say that you are in motion, you are moving. If both of us are traveling in one car, both of us are traveling in one bus, I will say that the other person is at rest. Sometimes we will be sleeping in the bus. So how can we sleep when we are in motion? But who is carrying us? Bus is carrying us. So along with the bus, we are in motion. Along with the car or along with the bus or along with any vehicle, we are in motion. Okay. So motion is relative when we compare with another person. That person also is in motion and both of us are traveling in one vehicle. We will say that according to this person, he is at rest. But according to the other person who is there outside the vehicle, according to this person, both of them are at motion. Okay. Now, if I am standing here, you will say that I am at rest. But whoever is observing from other planet, according to them, we are in motion. Actually, we are in motion every time, every second we are in motion only. How can we say that? Because our earth is in motion. What is that motion called as? Circular motion. It is having the circular motion and also rotatory motion. It is revolving around the sun in circular motion. It is rotating around its own axis, that is rotatory motion. So along with our earth, we are also under motion. So we can say that this point is correct. Motion is relative according to one particular person, according to some other persons who are traveling in a vehicle. Like that, we have to say that the particular person is in motion or at rest. Now coming to another topic here, kinds of motion. So you have learnt already in your 6th class what are kinds of motion. Like straight line motion, also called as straight line motion, can also be called as linear motion. Linear motion. Why we are calling it as linear motion here. Here linear means nothing but it is like a line, straight line motion. No, straight line motion. One person is traveling or one car is traveling here, which is in straight line motion. Okay, this motion can be called as a linear motion, or if you go to higher classes, you will get one word called as rectilinear propagation. Some different word you will get in higher classes. There again, don't get any doubt there. What is this new word? Rectilinear propagation. Straight line motion, also called as linear motion, and that only is also called as rectilinear propagation. Okay, now here along with this straight line motion, some other types of motions are also there. Like as I said, earth is rotating around its own axis, so we can call it as rotatory motion, and it is revolving around the sun, we can call it as circular motion. Now here I have some object in my hand. Let us take this marker as the sun, and let us take this cap of the or lid of this marker as the earth. Now this earth, if you see, it is rotating around its own axis. Around its own axis it is rotating. So if any object is rotating around its own axis, we can call it as a rotatory motion. But whenever this object is rotating, whenever this object is moving around it, another object in a circular path, we have to call this motion as a circular motion. Many of the students will get the doubts here in circular and rotatory motion. If any object is rotating around its own axis, we call that as rotatory motion. If one object is revolving around the other, we can call it as a circular motion. So our earth is in both circular and also rotatory motion. Because of the rotatory motion, we are getting day and night, and because of the circular motion, we are getting the seasons, we are getting different means year also we are getting 365 days is the time the earth is taking to revolve around the sun. That is a circular motion. Okay, now coming to another type of motion. Now we have seen rectilinear motion or linear motion. Next one more we have seen, that is circular motion. 1 minute. Circular motion, second one, circular motion we have taken. Next, rotatory motion also we have seen. Along with this rotatory motion, we are also having vibratory motion. You can see mosquitoes' wings, or if you see butterfly, or if you see any bird, whichever is going very fastly. Right, best example is you can take mosquito, or you can take butterfly. So whenever, if you see the wings of that, it will be moving very fastly. So this is called as a vibratory motion. In this vibratory motion, if you observe, it will be having one particular point as a reference. From that reference point, it is going to move to and forth, and that too very fast. So that can be called as a vibratory motion. Okay. Now coming to another type. So fourth one, you can write here as vibratory motion. Next, one more motion also we have here. What is that? Oscillatory motion. What is this oscillatory motion is? Oscillatory motion is nothing but if you are having one object. Now let us take the example of pendulum. If you remember the previous years, or now also we have in the clock, we will have some hand. So that it is going to move. That is called as a pendulum. That pendulum is going to move to and fro. So now just imagine that this is the pendulum. Now here this is a bob, and this is a thread we have here. Okay, so bob is there at the end. So here it is going to move from the reference point. This is the reference point we have. From here it is going to move to and fro. So same distance it is going to move to and fro. Okay, so this movement we can call it as a oscillatory motion. Okay, so like this we have different types of motion. In that, mainly here in this lesson we are going to discuss about straight line motion or linear motion. So that is our next topic. So what is that? Straight line motion. On that straight line motion, how to find out speed? Here for speed we have a formula. What is that? Speed is equal to distance by time. Speed is equal to distance by time. As I said now, how can we say that object is in motion? Whenever there is a change in the position of the object according to the or along with the time, whenever there is a change in the position. So So change in position is there means it has traveled some distance. Then we can call it as means the particular object has traveled, has covered some distance in one particular time. So that particular phenomena, that particular term you can use here, that is called as speed. So speed is equal to distance by time. Okay. So here, how to find out the speed? Now here, for example, one car is given here. It is covering 50 meters. It is traveling 50 meters in 2 seconds. In 2 seconds, it is able to travel 50 meters. So how to find out the speed of this car? So speed is equal to, we can write what is the distance here, 15 meters by 2 seconds. So what is the answer here? We got 25. And what we are writing here? 25 meters per second. 25 meters per second. Why we have written like this? Because 50 meters we have written here as a distance and 2 seconds we have written as a time. Okay. So 50 meters distance is travelled in 2 seconds. So if you see the units of this distance, we are writing in the form of meters. If you see the units of time, we are writing in the form of seconds. So that is why if you want to write the units for speed, you have to write meter by second. So that is why we have written here meters by second. If you go to higher classes, somewhere you can see MS inverse. So S inverse means what is the meaning here? 1 by S only can be written as S power minus 1. Okay. So just that is a extra point I have given here. No need to remember if you are unable. Otherwise, you can just write it as MS inverse. So M by S, that is nothing but meters per second. Or otherwise, we have one more unit also. What is that? Since mostly we will be getting the speed. Nowadays we are getting the speed in the form of kmph. We are calling it as kmph. What is this kmph? Is kilometer per hour. Kilometer per hour. Okay. So kilometer per hour also is one more unit, because here kilometer is the unit for distance and hour is the unit for time. Okay. So we can write here kilometer by hour as the units for speed. Right? Now, after this, we have to see one more thing also here. What is that? Uniform motion and non-uniform motion. Now, no need to worry about the calculations and all. In one more session, we will see about the calculations of this speed also. Okay. Now, we will see what is this uniform motion and non-uniform motion. Now, first, we complete what is this uniform motion. After that, we will see about non-uniform motion. Now, here we will take the same example, car. Okay. Now, in 2 seconds, it is able to travel 50 meters. And after some time, if you observe, in 4 seconds, it is able to travel some 100 meters. Okay. In 8 seconds, we have observed that it is able to travel 200 meters. Now, in these all, once we will try to calculate what is the speed of this car at every instance. At every instance, we will calculate what is the speed. What is the speed? Now, we are going to get here 50 by 2, 25 meters per second. And here 100 by 4, 25 meters per second. 200 by 8, here also 25 meters per second. So, everywhere we are having the same speed, 25 meters per second. So, we can call that this car is in uniform motion. Car is in uniform motion. We can draw one graph also for this. So, how we have to draw here the graph? We have to take distance on x-axis and we have to take time on y-axis. So, whenever we are taking like this, here we have to take the values whatever we have taken there, 50 meters, 100, 200, whatever we have taken, here we can take. Now, here every unit I am taking as 50, so it becomes 50, 100, 150, 200 like this, and here we can take the hours or seconds also. Here meters we have taken, so here I am taking seconds. So here let me take here 2, 4, 6, 8, because every unit I am taking as 2 seconds. Now before 50 and 2 just put a point, and before 104 put a point. Like that everywhere if you put a point, whenever you draw the line joining these all, we are going to get a straight line. So we can say that the graph between distance and time will be a straight line going through the origin, because this is the origin here, starting point. So From the origin, whenever we are getting this type of graph, whatever the graph we have drawn here, this is showing that the object or the vehicle is in uniform motion. Now, whenever you are drawing the graph for non-uniform motion, how you are going to get? Now, here only I will show. This car is able to travel 15 meters in 2 seconds, but 4th second, if you observe, it is traveling some 80 meters. Okay, now speed will differ. Now in 8 seconds again what happened, it is able to travel some 160 meters. Now we'll try to calculate what is the speed of this car. Now 80 meters by 4 seconds, 80 by 4, 20 meters per second, 160 by 8, here also we got 20 meters per second, 20, 20, 25. Different speeds we got. See here every time we have to get compulsory different, it is not like that. One way we have, at one point we have different, that also called as non-uniform motion. Okay, otherwise to understand clearly, let me write here some other value like 120 element. Okay, so 120 by 4 it becomes again 30 meters per second. Now here before 50 and 2, just to put a point here, 25, next 120 and 4. 120 where we will get between 100 to 150, somewhere here if I take it may become 120. So before 120 and 4, just put a point. Next before 8 and 160. 160 means somewhere here we'll get 8 and 160. So whenever you draw the graph, you are not going to get the straight line, but instead of that you are going to get a another line which is having some, it is not straight line. Okay, so it is not a straight line we are going to get. It is going through the origin, but it is not a straight line. So whenever we are getting the line like this, then we can call it as a non-uniform motion. It is not in uniform, it is not covered. How to define this uniform motion and non-uniform motion now? If any object is able to cover equal distance in equal intervals of time, that particular motion is called as uniform motion. And how to define non-uniform motion? When an object is able to cover unequal distance in equal intervals of time, or equal distance in unequal intervals of time. Anything you can say. One should be unequal, another one should be equal. Then we can call that type of motion as non-uniform motion. Right, children? So some more calculations and all we'll see in the next video. Thank you for watching, and like, comment and share my videos. Thank you everyone.